Okay, this is segment 4, properties and applications of logarithms. We've got 3 objectives: properties of logarithms, talk about the change of base formula, and some application problems. So, one application is for continuously compounded interest. Anne reads an ad in the paper for a new bank in town. Bank is advertising continuously compounded savings accounts in an attempt to attract customers, but fails to mention the annual interest rate. Curious, she goes to the bank, is told by an account agent that if she were to invest $10,000 in an account, her money would grow to $10,202 in 1 year's time. But strangely, the agent also refuses to divulge the yearly interest rate. What rate is the bank offering? So the way you would look at that, we learned the equation a little bit ago. A is equal to P, E to the RT. We're going to solve it for R because we know everything except the rate. The amount we put in is 10,202. No, that's our amount at the end. We put in 10,000 and time is for 1 year. Now you see that our unknown piece is in the exponent. Since our base is an E, we're going to use the natural log. But let's first divide the 10,000 into the 10,202. And we're going to get 1.020221 equals E to the R. Now we're going to take the natural log of both sides. And R, the reason it just goes to R, just for a little explanation here, what we've really done is we've got R natural log of E, but the natural log base E of E to the first, again, that's equal to 1. So that can just go down here as an R. So when we take the R times natural log of E, we end up with just R. Now we take natural log of 1.020221, or whatever it is, and that will give us our rate. And we get 0.02, which is 2%. Okay? Okay? Now this says solve the equation 2 to the x equals 9. We normally, when we had exponential functions, would say find a common base. Well, there's nothing about 9. I can't make 2 to some power. 2 to the third is 8. 2 to the fourth is 16. I can't make 2 to some power equal 9. So you end up taking the log of both sides. Excuse me. So we're going to go to they converted it to log of okay, there is a way to solve this. The way you would solve it is you would take the log of both sides. We're probably just not there yet in the course. It would be x log 2, not log base 2 because it's base 10. X log of 2 equals log 9. And then you would say x is equal to the log of 9 divided by the log of 2. And I don't have my calculator handy, but you could calculate that and get your answer for x. That's how when you don't have bases that match, that's what you're going to do. You're going to take the log of both sides. Okay. So, I'm not sure why we didn't just start with this, but the log of x times y is the same as the log of x plus the log of y. And the log of x divided by y is the same as the log of x minus the log of y. We do this to be able to take logarithm expressions and expand them or condense them to help us solve the equations. And logarithm rules, again, follow exponent rules. When we had 5 to the x, or 5 squared plus 5 cubed, the answer was 5 to the 2 plus 3, or 5 to the 5th. So we added our exponents. So when we multiply logs, we can also change it into an addition problem. When we divide logs, we can change it into a subtraction problem. If we have log base a of x to the r, we can bring that r in front, multiply it, and it becomes r log base a of x. Okay, so power When we have the log of something raised to a power, just bring the power into the front and multiply it by the logarithm. We'll work some examples. Now, I want you to notice how on the left, because that's x plus y, you can't change that to x plus y as separate. It's when it's x times y that you can change it into an addition problem. And so you have to be careful to follow the rules as they are written. You can make some common mistakes that are shown here. Same with division. If you have log of x divided by log of y, you can't subtract them, but if you have the log of parentheses x divided by y, then you can subtract them. And so we'll work some problems and hopefully that will help. So this says expand them. So we've got 64 times x cubed times the square root of y. So we've got three things multiplied together in a there. And log base 4. So you're going to end up with log base 4 of 64 plus log base 4 of x cubed plus log base 4 of the square root of y. We've separated everything that was multiplied together and added them. Now, if 64 is 4 cubed, so that actually has an answer. That answer is going to be 3. Then we're going to bring that 3 in front and the middle term. Okay. And they haven't shown the answers. They've just gone and shown that 64 is the same as 4 cubed. And rewrite your radical as a rational exponent. So instead of square root of y, you have y to the 1/2 power. Now we're going to solve number 1 and bring exponents in front of the second and third part. So we have 3 is equal to 3 log base 4 of x plus 1/2 log base 4 of y. And that's the final answer. They're not solving anything, they're just expanding the log expression. All right, now for this one, we've got all of this is a cube root of everything. So I would rewrite that as xy squared over z to the 4th to the 1/3 power. Or you could write the third power of the numerator, third power of the denominator. They wrote it all as 1. Okay? Now, you're going to bring the 1/3 in front, log base a of everything, the xy squared over z to the 4th. Now you're going to put 1/3 in some brackets, and you're going to separate these into sums and differences. Anything that's in the numerator is going to be added. Anything in the denominator is going to be subtracted. So we have log base x plus log base a of y squared minus log base a of z to the 4th, and the 1/3's in front of all of that in parentheses. Now we're going to bring exponents in front. So our final answer is 1/3 times log base a of x plus log base a, remember see the 2 comes in front, log base a of y minus 4 log base a of z. Alright, now here we have log, if it's not explicitly written, we know it's base 10. 2.7 times 10 to the 4th divided by x to the negative 2. Well, if it was me, I'd go ahead and rewrite that x to the negative 2 as x squared, because anything with a negative you can bring to the other side of the fraction line and make it a positive exponent. Okay. So it's 2.7 times 10 to the 4th, so you can say log of 2.7 plus log of 10 to the 4th minus log of x to the negative 2 power. Now, log base 10 of 10 to the 4th, that part's going to just be 4 when I solve it. Okay, this right here is going to be 4 because a base 10 of 10 to the 4th is 4. You can actually get an answer for log of 2.7, but you may want to just leave it for the exact, since you want it to be exact. Okay? And then we'll see what they're going to do with the negative 2 when it comes in front. Okay, they made it a positive, which is, okay, so log of 2.7 plus 4, negative 2 times minus is going to be positive 2 log of x. Okay? And that's your final answer. They went ahead and got the log of 2.7 and added it to 4. Okay. It says it's appropriate either to evaluate it or leave it in exact form. Hopefully the context of the problem will help you to decide which you need to do. So condensing them, this is putting them back the other way. If they're subtracted, it's going to become a division problem. If it's multiplied, or if it's a plus, it's going to go in the numerator if there's a fraction. So any numbers in front we want to put back up as exponents. So let's look at A. We have that 2 in front that will go back up as an exponent on the x over 3. You can say, bring that negative up as a negative 1, or you could put log base 3 of 1 over y in the denominator. Okay? So we have log base 3 of x squared over 9. They went ahead and did the 3 squared. Plus log base 3, 1 over y to the negative 1 is the same as y. There's a couple of different ways you could have written that. This one is fine. So, putting it back as 1, we're going to have log base 3 of x squared y over 9. Because it's plus, you're going to multiply them. Okay? Natural log of x squared minus 1/2 natural log of y plus natural log of 2. So this time they just put the 1/2 up on the y. So x squared, natural log of y to the 1/2 power, which means we're going to square root y plus natural log of 2. So anything that's positive is going to be in the numerator. And so when you end up with that, you're going to have 2x squared over y to the 1/2 power, or natural log of 2x squared over square root of y. Okay, bring your 2 up on top, and that makes it x to the negative 2. Okay, which is 1 over x squared. So it's log of 5 times x to the negative 2, or log of 5 over x squared. Okay. Change of base formula. You can kind of come at this without knowing this change of base formula, but it helps. If you have log base b of x, and you want a new base, use a base the calculator will do. Use an 8 or an e. So, I mean a 10 or an e. So you'll have log base 10, or just log of x, over log of whatever the base is that you start in your problem. So let's look at some examples. We have log base 7 of 15, and we want to use it either log or natural log. So for the first one, they're going to use natural log, so that means you do natural log of 15 over natural log of 7. Those are just numbers. You punch them in the calculator and you get a decimal answer. Okay? B, natural log, you have log of 3 base and 1/2. So you can use the log log of 3 over log of 1/2. Again, that comes out to be numbers. And C, log of 5 over log of pi. It could be log or it could be natural log. And you use the calculator. About one. And the reason those squiggly lines, it's about, is you're rounding it. You're rounding it to 3 decimal places. 1.406. Okay. There's several applications. The one I'm going to use mostly is going to be financial with interest. There's a pH scale, is a logarithmic scale. H3O plus is the concentration of hydronium ions in units of moles per liter. If you have a pH less than 7, they're acidic. pH greater than 7 are basic. Okay, and so this is a pH scale. The sample of orange juice is determined to have a H3O concentration of 1.58 times 10 to the negative 4th moles per liter. What is its pH? Okay, so you go to the formula, use a calculator. Okay, and the formula we had where? I don't see a formula. Okay. take the pH is the negative log of 1.58 times 10 to the negative 4. And that's going to be negative 3.80 or 3.8. So it's on the acidic side. It's below 7. Okay. The Richter scale, earthquake intensity, is measured on the Richter scale. And the formula for I sub 0 is the intensity of a just discernible earthquake. I is the intensity of the earthquake that's being analyzed. R is its ranking on the Richter scale. So, by this measure, there's some ranges of small, moderate to large, and major, and then some greatest. So, here we have January 2001 earthquake in the state of Gujarat in India was 80 million times as intense as a 0-level earthquake. What was the Richter ranking of this devastating event? So we have I as the intensity of the Gujarat earthquake. Is 80,000 times I0. So 80,000 times I0 over I0 is going to be the log of 80 million. I keep saying 80,000. It's 80 million, which is log of 8 times 10 to the 7th, which is the log of 8 times the log of 10 to the 7th, which is 7, or plus, excuse me. And that's 7.9, so it's in the category of the greatest on the Richter scale. Okay, decibels is sound intensity. Again, I over I0. Range from 0 to barely discernible, 40 for level of conversation, 80 for heavy traffic, 160 where your eardrum will likely rupture. So, decibel level of jets, airliners, engine. At a distance of 45 meters, for which the sound intensity is 50 watts per meter. And they give you I0 is 10 to the negative 12. Okay? So we have 50 over 10 to the negative 12. And was that 10 part of the... Yeah, 10 is part of the original formula. Okay? So we have log of 50 divided by negative 12. 10 to the negative 12. Which ends up being 5 times 10 to the 13th. Take the log of that, which is 5 plus the log of 5 plus the log of 10 to the 13th. Okay? Which the log of 10 to the 13th is 13. And so it's going to be 137. It's louder than a rock concert, but not enough to split your eardrums. But it's very, very loud. Okay. That will... they didn't have any financial examples. Those are the ones I prefer. I think there may be a few on your homework.